One.
Hello students, and welcome to our second video. In this lesson we're going to be focusing on the basic angle pairs that we need before we really dive into our year. So you've got your blank note page here, and you've also got maybe a couple different colors if you really like to highlight some things. I've got this first little section of review here about classifying angles that you could probably do on your own. In fact, take a second and see if you can remember the angle measure that is a boundary for an acute angle and the angle measure that it takes to be a right angle and obtuse and so on. We're looking for the degree measure here. So take a moment and see if you can remember those degree measures. Okay, so for an acute angle, let's see what you came up with. An acute angle is an angle that measures between 0 degrees and 90 degrees. Okay, so if I get out my protractor here and show you my protractor again, 0 degrees is way down here and 90 degrees is up here. So anything that's less than 90 degrees is an acute angle. A right angle is an angle that measures exactly 90 degrees. An obtuse angle is an angle that measures anywhere between 90 degrees and 180 degrees. So that's a nice wide angle. And then maybe you've never heard of a straight angle before. A straight angle is an angle that measures exactly 180 degrees. So maybe that's something you already knew. Hopefully that was just a quick review. Those are just some words that we'll use to be classifying angles to make our vocabulary a little stronger. Now for something new. Okay, we've got other ways of describing angles. The first is to describe an angle as adjacent or non-adjacent. So let's talk about the word adjacent. Adjacent means next to, beside. My orange pen is adjacent to my green pen. They're side by side. Okay, adjacent means beside. So adjacent angles are two angles that share a common side, so that they're side by side, and they also share a common vertex. That's a vocab word we learned last video. And with this common side and common vertex, they do not overlap. They do not overlap. So let's take a look at this example here. We've got angle ABD. Here's where some colors might help out. We've got angle ABD. And it is next to or beside angle DBC. Angle DBC. So we can say that angle ABD shares this side. It shares ray BD, and it also shares this vertex B. So this is our common side. That's ray BD. And this is our common vertex, point B. So in this picture, we've got adjacent angles. They have a common side and a common vertex. So we can say that angle ABD is adjacent to or right beside angle DBC. All right, let's look at a few examples of non-adjacent angles, okay? I've taken the exact same picture and I've brought it over here because I wanted to show you how you could have the same setup but really be looking at non-adjacent angles. Let's start with angle ABD again, okay? Angle ABD sort of that top angle. Remember, A to B to D. And let's compare it to the largest angle, angle ABC. Okay. Angle ABD and ABC. Well, if I'm reading through the definition of an adjacent angle, it seems like I'm doing okay. Two angles that share a common side, so there's a common side, and a common vertex, but here's the kicker. Do not overlap. If you look at this picture carefully, angle ABD, the orange angle, is completely inside of angle ABC, the green angle. So these are non-adjacent due to overlap. There is no overlap in adjacent angles. So that's a set of non-adjacent angles. Our next pair over here on the right, we've got angle GEF. Whoops, moving the paper around, sorry. And angle HJI. Well, I hope you can see why these are completely non-adjacent. They have no common side and they have no common vertex. In fact, they're not even beside each other. They're just completely separate from each other. So let's make a note here. No common side. Or vertex. They're just a mess. Okay. All right, for our last example, we've got something that kind of looks like a Z here. Let's check it out. The two angles I'm looking at are KLM. Outline that one. KLM. Okay. KLM. And let's compare that one with angle LMN. LMN. Okay. Now those certainly look side by side. They're connected. They're right there together. They have a common side here. LM right down the middle is a common side. So what are they missing? Look at that definition again. Two angles that share a common side and a common vertex. They must share a common vertex. In angle KLM, this is the vertex. In angle LMN, M is the vertex. So they do not share a common vertex. No common vertex. Okay. So there's three examples of non-adjacent angles. It's a pretty specific example, but I also think it's a pretty simple concept if you kind of just weed through the details. The angles have to be side by side. They have to share a common ray, and they have to share a common vertex point, but they can't overlap. Whew. Okay. Our next concepts are maybe something you've seen before. We've got complementary and supplementary angles. Okay. You may remember the definition of complementary and supplementary, or you may be able to take a look at the picture and get a good idea. Complementary angles are two angles whose sum is, take a look at this picture here or do a little mental math and you'll come up with that blank, whose sum is 90 degrees. Complementary angles are two angles whose sum is 90 degrees. So this one's pretty easy to do, the one here on the right. We've got a 15-degree angle and a 75-degree angle. 15 plus 75, there's your 90 degrees. So those are complementary angles. This one might be a little trickier because there's no angle measurements in the picture. So I want you to notice a symbol that's very, very, very important here. I'm going to highlight it. It's this box. Okay, the box you see in the picture symbolizes that this is a perfect right angle. Box symbolizes that angle ABC is a right angle. Angle ABC is a right angle. So if ABC is a right angle and it's 90 degrees, then these two angles inside of that 90-degree angle would have to have a sum of 90 degrees. So we may not know what the measurement of angle ABD is, and we may not know what the measurement of angle DBC is, but we do know that if you add those two measurements together, it's going to equal 90 degrees. And here's how we'd write that. The measure of angle ABD plus the measure of angle DBC is equal to 90 degrees. That's a mouthful right there. And it says basically the same thing that this does, but here we know the exact measurements. I want to also note that you've got a couple more examples of adjacent and non-adjacent angles. Here, angle ABD and DBC, there they are, side by side. This is an adjacent angle pair. I'm just going to write that note up here so you have another example where these two, angle P and angle Q, are completely separate from each other. They don't share a common side. They don't share a common vertex. These are non-adjacent. So complementary angles are any two angles who have a sum of 90 degrees. They can be adjacent or they might not be. Complementary is often taught with supplementary because it's really the same concept but a different angle measure. Supplementary angles are two angles whose sum is 180 degrees. 90 degrees and 180 degrees get used a lot in geometry. So let's take a look at what we have here. In this first picture on the left, we've got a set of adjacent angles. Okay, angle ABD, we could also call that angle 2, is adjacent to angle DBC. Okay. One thing to note is ABC, angle ABC is a straight angle. Take a look at your notes at the very top of the page. A straight angle has a measure of 180 degrees. Well, a straight angle does look awful lot like a line. In fact, a straight angle is a line. But this angle that's been measured is 180 degrees. So it's worth noting that angle ABC is a straight angle. Use my angle symbol there. And a straight angle is equal to 180 degrees. So if you take the two angles that make up that straight angle, that would be the measure of angle ABD added to the measure of this second angle DBC. Add them together, and you're going to get that straight angle. You're going to get 180 degrees. Our second example is much more simple. We've got two separate angles. They've already been measured with a protractor for exact measurement, and we can just do the math. 75 degrees plus 105 degrees makes 180 degrees. So these two are supplementary angles. Read that note again. Supplementary angles. Two angles whose sum is 180 degrees. Our first picture on the left is an adjacent set of supplementary angles. Our picture on the right is a non-adjacent set of supplementary angles. So they can be connected or they don't have to be. All right, let's flip over and see what else we've got here. Oh, well, this angle pair looks pretty familiar. Look at that. I just took the picture off the front and brought it over here to the back. So that means, oh, there comes one of my kiddos. I'm going to pause for a moment and see what all my kiddo needs. 1 second. Okay, I'm back. That was my little buddy Nathan. He just needed some mommy time. Okay, so next we're looking at a linear pair. Again, we've already seen this picture on the front, so let's just organize our thoughts here. A linear pair are two adjacent angles, right? So they must be side by side, whose non-common rays, like ray BA and BC, are not common to both angles, are opposite of each other. So they form a straight line. I think that definition is a little tricky. Okay, I think that's a tough one. Two adjacent angles whose non-common rays are opposite. That's pretty tough. Here's what I think you need to know to really keep linear pair in your mind. Supplementary plus adjacent equals linear pair. If you've got a set of supplementary angles that are also adjacent to each other, they form a linear pair. Another good way to remember this is linear has the word line in it, and they form a straight line. Two angles that are adjacent that form a straight line are a linear pair. What we could do to prove this here is we could actually measure this angle. I've got my protractor here, and as you can tell, the printout is a little too small for this giant protractor. So here's a little trick. I'm just going to grab a pen here, and I'm going to extend our common ray. There it goes, all the way on up. And now I can measure. Line up my protractor right on the vertex. Measure it out. There we go. And it looks like we're cutting right through 132 degrees. That might be kind of hard to see on the video. 132 degrees. So that means this obtuse angle is 132 degrees. And this acute angle, well, there's two things we could do. We could measure again with our protractor, or we could do some simple math. If these two angles add up to 180 degrees, then 180 minus 132 leaves me with 48 degrees. So this other angle is a 48-degree angle. Okay, so a linear pair, adjacent and supplementary. Couple more to go. Now we're talking about congruent angles, and we are going to have a lot of congruent angles throughout our year, but this is a great place to start. Our first set of congruent angles are called vertical angles. Vertical angles are two non-adjacent angles formed by intersecting lines. So non-adjacent, which means they do not share a common side. So let's take a look at angle AED. I'll trade colors here. Angle AED has a vertex at E, and the two sides are EA and ray ED. So to be non-adjacent, I can't choose any angle that uses EA, and I can't choose any angle that uses ED. So the angle that's considered vertical to this angle is straight across the x. This is a set of vertical angles. Angle AED and angle CEB are a vertical pair. We have another set in there too. Take a look here. Angle DEB. Angle DEB goes straight across the x, and angle DEB is non-adjacent to AEC. So angle DEB and angle AEC are a vertical pair. What's really, really, really important to know about vertical angles is, if you notice, take a good look, vertical angles are congruent to each other. Acute angle, both green angles are acute. Obtuse angle, both orange angles are obtuse. So let's make a really big note about that. Vertical angles are congruent all the time, every single time. They are equal in size. Another way to make congruent angles is to use what's called an angle bisector. An angle bisector is a line or a ray that divides an angle into two congruent angles. So in this picture, we've got the big angle, CAD, and then we've got this line cutting right through the middle of the angle. Cutting right through the middle. How do I know that that's exactly through the middle? Well, look at these markings here. We've got that congruent measure mark in there. So that means that this line is a bisector. It's cutting the angle in half, creating two congruent angles. So now, because this is a bisector, we could say angle CAB is congruent to angle DAB. They're congruent to one another because we have a bisector. And that's ray AB that's doing the bisecting. Okay, so that's a ton of information. That is a lot going on. Let's do a little bit of practice here to kind of work our way through some of these thoughts, okay? What our goal is to find all the missing angle measures given whatever angle measure we have, okay? So we're going to try and use everything we know, everything we've discovered so far. So take a look at the first example on the left. This is a classic two-line intersection. Makes a nice bow tie shape, okay? And we've got a lot of vertical angles going on in here. In fact, 67-degree angle is vertical to angle 2. And what do we know about vertical angles? It's right here in purple. Vertical angles are congruent. So that means that angle 2 has to be 67 degrees also. Okay. We've also got a whole lot of linear pairs going on in this picture. Let me cover this up. Take a look at angle 2 and 3. Angle 2 and 3 are adjacent to one another, and they live on a line. They are supplementary. They form a line for that linear pair. So adjacent and supplementary, that's a linear pair, and we know that that adds up to 180 degrees. So quickest way to find angle 3, 180 degrees minus 67, and whatever is left over gives me that linear pair. That would be 113 degrees. Hopefully hopefully angle 1 is standing out to you now. Angle 1 is vertical with angle 3. And if vertical angles are congruent, then right away I hope you'll just transfer that 113 down here. They are congruent to one another. So knowing one angle kind of unlocks the other 3. Now, next we're getting pretty busy. We've got 3 intersecting lines, so our bow tie is a lot bigger. We still have a lot of vertical angles. Let's start there with vertical angles. Let's start with our 103. 103 degrees. Travel straight across the intersection out the other side, and that is vertical with angle 3. So that's 103 degrees. The 35-degree angle has a vertical pair. Go straight through the intersection out the other side, and you'll line up with angle 2. So it must be 35 degrees. So how on earth do we find that missing angle pair? Whatever angle 1 is going to match up with angle 4, but I'm not exactly sure what either one of them is. Well, I've got my sticky note handy again. Let me cover some stuff up. When I cover half of this picture up, you'll notice we have that straight angle in there again. There it is, that 180-degree straight line. So all 3 of these angles cut that 180 degrees into different pieces. So in order to find angle 4, we need to subtract these other 2 from 180 degrees. 180 degrees, subtract away the 35, subtract away the 103, and whatever is left is angle 4. I'm getting 42 degrees. So angle 4 is 42 degrees. And its vertical partner is also 42 degrees. Ooh, that's a toughie. Lots to keep up with there. I've got one more here for us to try together. Take a look at what we have. We've got vertical angles all around, and then we've got this extra ray in here that does not have a partner, and we've got this little box. Try and think back to what that box means. That box represents a 90-degree angle. Okay, so where should we even start? Let's see. Well, let's start with vertical angles since we've been talking about that a lot. It looks like 44 degrees has a vertical pair. Goes straight through and out the other side. It matches up with angle 1. So there's a 44-degree angle. Angle 2 and angle 5 are a vertical pair, but I don't know what either one of those are. Angle 6 does not have a vertical pair because this ray does not continue. And the 65-degree angle does not have a vertical pair because the ray does not continue. So we're kind of done with vertical angles. Let's use this 90-degree box next. 90 degrees is a complementary set of angles. So angle 6 and that 65-degree angle right there are complementary with one another. So if we have 90 degrees to spend on these 2 angles and we subtract away the 65 that's already used, then we're left with 25 left over for angle 6. There we go. We're getting closer. Now remember, neither one of those is got a vertical angle straight across. So out comes my sticky note again. Finding a straight angle. There's a straight angle, 180 degrees, and it's been sliced all up. We've got 65, 25, 44, and something for angle 5, something. So 180 degrees, if we subtract away everything else that's there, what's left is angle 5. So 180 Subtract away the 65, 25, and 44 leaves me 46 degrees for angle 5. Which thankfully has a vertical pair. Check that out. Follow straight on through. Angle 2 is its vertical pair. Now there's 2 ways we could go after angle 3. I could use my sticky note and find another straight angle and do another subtraction. 180 degrees for the straight angle. Subtract these 2 parts away. Let's see what we get. 180 degrees, subtract the 44, subtract the 46, leaves me with 90 degrees for angle 3. Hopefully that number rings in your mind because we just used this 90-degree angle. Look at that. You've got another set of vertical angles. There's just a little overlap going on. I'm going to highlight the lines that make those vertical angles. These highlighted lines show us another set of vertical angles. Ooh, that was a lot. Thanks so much for watching.